The main idea for today is that we want to confirm the relationship that the a square and the b square, the two smaller squares, add up to the big square c squared in a right triangle. So that's the important thing for today. We're going to do some calculations to make sure to confirm that this is really true and it actually works. So what we're going to do is we're going to take a look at this a square here, this b square here, this c square here, and we're going to calculate, do some measurements. We're just going to count, and we're just going to make sure that a squared plus b squared actually equals to c squared. And we want to make sure that we understand that a plus b does not equal to c. So that's one thing I write down. I'm going to do this in red. A plus b is never equal to c. Okay, the length a, this length here, plus this length here, will never be equal to the diagonal length. When we add this and this together, it can never equal that third side. Okay, so we never want to do that. Okay, so let's try the relationship in terms of the area. So the length of side A, let's count. Length of side A, we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have an edge length of 10 squares. Okay, so we'll just say this 10 units. Let's calculate the length of side B. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's also 10 units. Oops, that's not 10 units squared, that's 10 units. The area is going to be when we square that area. So side B, when we square that, 10 squared, we can count up the number of squares here. This is a 10 by 10 square, and that's going to be 100 squares. So a squared is 100 squares, b squared is 100 squares. They're both the same square. So that's going to be 100 here. And what we want to do is we want to check that c squared is going to be the 200 that we expect. So we're going to break up the c into triangles and calculate c, the area of c squared. So this is going to be 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to the corner. So we know that's going to be 10 times 10. It's a triangle, so we're going to divide by 2, and we're going to get 50. And we can start seeing that if these are each 50, 50, 50, 50, 50, we can actually make a square from these two triangles, and that actually will give us if I put those together, kind of put the diagonals together, I'm going to actually end up with this area here, the same area. And so we can see that we have 200 squares that make up that c squared. So c squared, we're going to say is 200. That's going to be squares. Okay, those are not lengths. So we've counted up the c squared here. Okay, I'm just going to shade it to make sure that we know that that's going to be 200. So that's going to be all that c squared is going to be the 200 that we found. That makes the length of side C, we have to square root it. The square root of 200 ends up being 14.14. Okay, that's units. So that edge length then is longer than A and B, but it's not A plus B. A plus B would be way too long. Okay, 10 plus 10 is going to be way longer than the actual edge length of 14.14. So we have a squared plus b squared is going to be 200, and that confirms that a squared plus b squared, okay, these two areas here, a squared plus b squared, these two square gives me 200, and it also matches the diagonal square, which is what I want.